What are the startup tasks? So they are actually introduced in Windows Azure SDK 1.3. They are commands which are executed before your role is started. They're generally scripts, like you can say batch files, command files, or some kind of scripts or executables which you want to do. This adds lots of flexibility to Windows Azure. I mean, take some example. Before your application, when you are running a web role, you need to set up few things in IIS, some custom settings. You can do that through startup task. If your web application needs few custom components or some installers to be run on that virtual machine before you start your web role, startup task is the way to go out. So these tasks are executed before the role is getting started. Why do we need startup tasks? As I said, sometimes setup is required before execution at the top of the code. At the top of the code isn't good enough. I mean, so we need few DLLs, few assemblies, or few installer to run before actually we consume them in our role. And we do not have complete control of VM, right? And that is where we make use of this startup tasks. We have multiple types of startup tasks. One of them is elevated and non-elevated. So elevated startup task has administrator access. So all the registry settings and other things which we want to do, we can do through this. For installing some few specific things and making use of that in Windows Azure platform, you might use VSD like VM role, but that would be overkill. I mean, you might have to set up everything on your local desktop first, create that VSD and try to upload it. If there is a change, again you do the same thing. But here, that using startup task, you can avoid that. You can just run some of the MSI files, and you can execute some assemblies using the startup task. We are going to see one example where how do I install my COM component, VB6 COM component on Windows Azure machines, Windows Azure Virtual Machine as a startup task, so that it is all the time available whenever the role starts. So there are multiple options. You define the startup task in service definition file. You can say I need elevated access or not. You can set and use of environment variables. If there are some of the startup tasks which might need some environment variables. For example, if you want to install some third-party component, they might look for some environment variables already. So you can set it up in your definition of startup task and make use of them in the startup tasks. There are 3 modes available. One is simple. Most of the time I use simple, which is like by default. If you don't mention it is simple. It is synchronous. So first it executes all the startup tasks, and then it will go to the role life cycle. So it is synchronous. In asynchronous, we have 2 options: foreground and background. Foreground, it blocks the shutdown. If there is something wrong with your VM, it is not going to get shut down unless the foreground tasks are completed. In case of background, they don't block the shutdown. So if there is something wrong with the VM and it is going down, you can actually background processes, the background startup tasks do not interrupt the shutting down of that VM. So the best practice, generally we use simple because that is what we want. We want to install all our assemblies, all our third-party components before the role starts, and that is where we make use of simple. We'll see demo of it in the code once we see the once we go to the Visual Studio. Few tips, as we said, startup tasks are generally scripts, and I generally use batch files or command files to run my startup tasks. So log everything. So all the commands you can redirect to your any text files, output of that to the text file, and you can also output your errors to another text file. So these are the DOS commands specifically. You can redirect to the text file. R2 is like for errors. Use override like /y as a parameter in everything wherever you are using any startup tasks like batch commands. So it will not wait for any input from you. Y stands for passing the yes parameter to your DOS commands. You can make use of local storage, which is because for that specific instance of VM, when it is starting, you already have that space available for you. Reboots are fine if you need to reboot your virtual machine after installing something. Like there are few installers which we have used in Windows Azure which needs restart of the VM. That is okay. So because it restarts, it comes back again and start taking the same events. But don't even go to any infinite loop, because if you go to the infinite loop, your status of the role will always be like ready, busy, initialize, and all those kind of things, and it is not available to the end user, and it will always go in the infinite loop. You are wasting your money and time on setting up the VM. You can just use of this command to check the local system also, and while using the batch files, generally we suggest using exit/b0 just to come out of that batch file rather than using some EOF kind of commands in our DOS file. So these are basically some few tips which we need to be implemented in our batch files to make best use of the startup tasks. When not to use startup tasks? I mean, if there are long manual fragile installations, as we said, if we need to install something like, imagine Oracle, if you want to install Oracle, I mean, probably startup task is not the best way to do that, because it's a completely new software. It is going to take a lot of time. It is very fragile. So it's for those kind of things, it's better to use VM, create your VM locally, install Oracle on that, and then upload it to Azure and make use of it. I mean, that is one example which I could think about. There could be lots of things like any custom softwares which needs long and manual interaction with your installation procedure that can be done through this. Okay. Things that require IaaS pool to exist already. I mean, you don't use a startup task for that, because the role instance, when it is starting, the IaaS pool is not ready, and you should not assume that when you are writing your startup tasks. If you are writing some processes which needs to be monitored for most of the part, do not use startup task for that. The easier way is to execute that process from your web role or worker role using process.start and wait for it exists. That is how you can monitor that. Not really. We don't really need startup tasks for that. There's another option underneath your service definition file, runtime section. We have a program entry point. You can just set up an exe there, and it keeps running all the time. We'll see that also in our demo. So after talking about startup task, as we said, role entry point. So we have custom role entry points for that. You can run any executable in your code, and it is not limited to .NET code. You can write any executable like C#, or C++, or any other executables or batch files for that matter, and you want to run that once the role starts, and that is where the setting is, role entry point. It is a new settings which was added in Windows Azure SDK 1.5, I think. Yeah. And once that role entry point exe which we have given access to, if it stops, your role also automatically restarts. That is how you define your custom role entry point. So here in your service definition file, you have, for example, in worker role, I have runtime execution context as limited, and that's where I say entry point. An entry point, I can say my program entry point is command line my process.exe. Set ready on process start true. It means once the process starts, set the status saying that it's ready, and the VR worker role is going to be ready for that matter. There is another type of role entry point where you can execute an assembly. You can just run an assembly with a specific interface which Azure has provided, and you can make use of that as NFX entry point. Yeah. But for most of the purpose, like if you want to keep running some of the EXEs and you want that to be done through a program entry point, this is the way to do it. Okay. Now, after talking about, I think we are covering small topics, but they are very important in the advanced scenarios. We are going to see them one by one in our Visual Studio demo. Before I go to the next topic, I just want to touch base on the topics which we have seen. We have talked about fault domains, upgrade domains. We talked about startup tasks. We talked about role entry point. We talked about local storage, and now we are going to talk about role environment communication. So if I have multiple roles in my system, in my Windows Azure project, I could have like web role, worker role, I could have two worker role, one web role, that kind of scenarios. So how do they communicate? There are two ways to establish that communication. One is a synchronous communication, which can be done through an internal endpoints. So internal endpoints are direct communication, or it is like you have an internal endpoint available to only those roles. They are not available from the outside. To make use of internal endpoint, these applications, these roles should be part of the same application deployed to the cloud. For example, I can have one cloud project or package which includes two roles like web role and worker role. If I make use of internal endpoint and I deploy them in the same package, then I can make use of this internal endpoint. Otherwise, I cannot communicate to them. It is a channel-based communication. So you can use service host to communicate on internal endpoints. You can use TCP endpoints, for that matter, to communicate with other role. Control the communications, and if you want to control how multiple roles are going to communicate, what kind of rules you want to set up, you can do that in your network traffic rules setting in service configuration, service definition file. We'll see that. There are a few scenarios which I have just tried to put it from MSDN. Like scenario 1, web role talks to worker role using direct internal synchronous communication. In scenario 2, web role talks to 2 separate worker roles independently. Scenario 3, web role talks to one worker role 1 and worker role 1 talks to worker role 2. So these kind of rules you can set up using the network traffic rules in your service definition file. Synchronous communications are, you have to be very careful about using it, because it is as good as if you send a request from web role to worker role, your web role is still waiting that process to complete, and till the worker role comes back with some response. And in case at times synchronous communication is not the best way to implement decoupled systems, long running processes, etc. So for that we have queue, where we'll just see what is Windows Azure queues quickly, and we'll see how we can make use of it for establishing asynchronous communication between